All right, hello everyone. So I'm Christoph. There's Rick and Rubén behind the camera. Recently, a bunch of people have talked about the Jest architecture on Twitter, and also the Jest project is growing quite a bit, so we obviously want to have new contributors. A few months ago, I did an overview of the Jest architecture, and today we thought we'll just do the same thing again and record it and then share it online so that you can watch it. And basically, I'll just go through what it takes to run one test with Jest, because there's actually quite a lot behind that. And also, I'll explain the architecture of how Jest works. The thing to note here is that this wasn't something that was planned initially. It wasn't like, oh, here's how we're going to build Jest, and here's how we're going to build the ideal test framework. It's stuff that happened over years, actually, and how all of this was pieced together. That's what I'm going to go over. The other thing that's important to notice here is that it's not perfect. It's not the ideal system. It's just the system that we have right now, and hopefully we can identify some things to improve, but also I hope that it gets better, because it's definitely not perfect. It's just what it is right now. So to start, I'm just going to put in a command. That's how you might know Jest. So on the command line, you might write Jest, and then you say, run this test. So I'm going to use red for pretty much anything like commands and variable names and stuff like that. And then I'm going to use green to mark packages in Jest. So one important thing is that the Jest project is actually split up into multiple packages. So I think it's more than 30 different packages. So if you look at the Jest repo, there's a folder called packages, and in there's a bunch of packages. Those are in green here. So the first one we're going to talk about is the one that's called Jest CLI. All right. And then you can find that in the Jest repo. The important thing about this one is that actually most people install the Jest package, so it's just called Jest. This is just a legacy reason. We used to only be able to publish the Jest CLI package, and we only got ownership for the Jest package much later. At that point, though, we didn't want to make a breaking change so that people who were using Jest CLI would have to change anything. So in that case, we actually just make it so that the Jest package forwards to Jest CLI. Both of them are pretty empty, so there's not really much going on there. The Jest CLI package does pull together all the other packages, though, to run a test. So basically, you call Jest with my test. It goes to Jest CLI. The first thing that we do is actually we talk to a package called Jest config. That's the first thing. It's called Jest config. This package is important to figure out what the person invoking the command actually wants to do, or what should happen on a CI environment. It takes the config that is specified somewhere in a configuration file, like package.json or Jest, Jest.rc.js or Jest.rc.json can be one of those. So it takes that config. It also is responsible for actually finding that config, what I was just talking about, but also it takes the arguments that were made to that call, and then it merges them together and figures out what we actually want to do. So we have a function called normalize in this package. And then I'll use a different color. Blue is for types. So it normalizes the data that we get for this invocation. And then it creates two separate configuration objects. So in the past, we only had one configuration object. It was just called config. So it's like config, and it would take those two, figure out what has to run, and then just run that. Still good?
No, you're off the
Cut
screen.
off. All right, I'll move over a little bit. How far can I go?
To normalize.
This far? This far? Okay.
Yeah.
All right. I'll stick to that.
we were measuring using the pre-record thing.
Yeah, that's all right. Okay, we're making some adjustments. We're all learning here. So in the past, we had something called config. Nowadays, what Jest does is it actually creates two objects. One is called a global config. That's erased now. Oh, great. Okay, so we have a global config and a project config. So everything from how many workers to use, which test framework to use, which timer system to use, which modules to mock and unmock, what are config options we have, whether it's a verbose run where it prints more data, also which test reporters to run, anything else that's in your mind?
Or there's a ton of them.
Ton of configuration options. One of the important things here about Jest architecture is actually that Jest really has a lot of ways to configure itself. Other frameworks or libraries, they might not have that many configuration options, but Jest has like a ton of them. And this usually seems like a bit like a code smell, and there might be some problems associated to it, where it's hard to maintain, or you run into some issues where you just have to make breaking changes all the time. In practice, though, with Jest, we haven't really experienced that. We tried to make it so that it's very easy to configure, that it has great defaults, so you don't really need to configure it, but also that when you can really customize it to any way in any way that you want. With this package architecture, as you'll see later, you can swap out pieces and then not be affected by specific amounts of configuration. So anyway, going back, so Jest creates two different types, global config and project config. So you get some, we call the normalized function, and then you get out the global config and the project config. This is important because in the past, as I said, there was only one configuration object. Now there's two, but also there might be more than one of these project configs. I'm going out of the picture.
Yeah.
So this is bad. What do we do?
The
Can you move the camera?
the board is in the picture.
Let's move the camera a little bit.
Nope.
That's good.
All right, good. Now I'm in the picture again. Great. This is like we haven't figured out the video stuff here yet, but we're working on it. Anyway, so I'm going back to the config. So there's always one global config, and global here means it's global to this Jest run. So you invoke Jest like this, you have one instance of a global config. For project config, most of you who are using Jest only have one of these. However, for example, at Facebook or at places where you have a lot of different repositories or a lot of different projects, where you run Jest and have separate configurations for each project. For example, one front-end project and one server project, and both of them are using Jest with different configurations. One of them might use the JS DOM as an environment, that's your front-end project. The other one might use a Node environment for your tests on the server on the back-end. So you might actually have more than one project config, so you can have one-to-n project configs. This is going to come in handy later because the interesting thing about Jest is that it can use one global config and many project configs to run many tests from different projects in a single test run. So just to explain quickly, global config, the great thing about that is that it has all the information about that run. So for example, the reporters that you're using to output results, that is part of the global config. The amount of workers that you use to parallelize the test run, that is also part of the global config. For the project config, as said already, you might use a different test environment. You might use a different setup for transforming files. So, for example, on the front end, you might want to use Babel transformations, and on the back end, you might not even have any transformations. So that goes into project config. There is a types folder in the Jest repository, and all the flow types are in there, so you can read up and easily figure out what each configuration object is there for. It has one overall config object for everything that you can feed into Jest, but also specific types for the global and project config, so you can figure that out there. Anyway, going back to Jest, so we call normalize, we get a global config and a project config back, and then we just send that back to the Jest CLI. So now we know kind of what test we're running and what the configuration associated with that test run should be. One of the things that we need to figure out now is actually what is the code base that we operate on. So Jest actually does a lot of static analysis to figure out how to run tests really quickly, but also how to do dependency resolution to figure out how to track specific changes from files back to which tests are affected by that change. So for that, we have a package that we call Jest Haste Map. All right, that's the third step. So Jest actually calls this package, and it's asking, hey, what are all the files in the project, and what are their dependencies between them? And that obviously is a very time-intensive process, because it actually has to get a list of all the files in that project, and you might have a very gigantic project like we have at Facebook for our entire code base. And then it also asks, okay, and give me all the dependencies between different files. The way it does that is actually it looks at require calls or import calls with ES module, ES imports, and extracts them from every single file, and then builds up a tree. Well, actually, it just builds up a flat map that actually has every file in it and all of its dependencies. So through that, you can traverse the tree and figure out what the dependencies are between modules. So the thing that is created here, there's also a type that we call haste context. There's a lot of contexts. So this one is just called haste context. And that haste context has something called a haste FS, which is just a haste file system. I should also give some background here what haste means. Haste is basically the module system that we use at Facebook that has existed from the time before we even had CommonJS, so that's like 7 or 8 years ago. And the idea of haste is actually at Facebook, the way we use it is we have one folder where all of our JavaScript goes. It's called HTML/JS. That's in our big repository. All of the JavaScript is there, a lot of files. And in there, every file has a name associated with it. That name used to be inside of the file, and if you're using Facebook Open Source Project, you might have seen a header in a file that says add provides module and then a name. So that used to be the global identifier for that module. And what you can do at Facebook is actually you can require every module by name, so you never have like a long relative path. Which one am I using? Like a lot of projects, you might have like paths like this, where you require a module. .js. That just doesn't exist at Facebook, so you never have relative requires that are really hard to understand. You basically just require a module called module, something like that. We actually have recently changed this, also thanks to Rubén, so that we actually just use the name of the file. So we don't have to read the files to know what their ID is. That was just a small optimization for upfront computing. But basically that's haste, and that's just the system that we have at Facebook. The good thing about just HasteMap is you don't have to worry about any of that. What it does though is it does do the static analysis of your repo and the dependencies in between your code, so that it can figure out which tests to run and how to optimally run them. So just going back here, when I say HasteFS, that means a haste file system, and that is really just a list of all the files in your system and all the dependencies that are associated with that. The interesting thing here, as I said, is that it has to get a list of all the files, right? So one thing that it does is it invokes something called Watchman. If you have Watchman installed, that's another Facebook open source project that is aimed to notify you of file system operations. So basically you say, hey Watchman, what are all the files that exist in this folder? And then it gives you a list of all of those files. And then you can actually, when you stop running Jest and you run Jest later again, you can ask it, okay, the last time I asked you, you gave me this list. What are all the changes that have been made to the file system since then? And then it will only give you a list of those changes. So it will say, okay, this file has changed, this file has been deleted, this file has been added. And then that means that Jest actually, Jest HasteMap has a cache where every time you invoke Jest, it doesn't do all of these operations of like listing the entire file system and reading all the files. It only does that one time, stores that in a cache, and on subsequent invocations, it asks Watchman, hey, what has changed, and like, what do I need to do? If you don't have Watchman installed, it will just use a Node crawler, a Node.js crawler that is like handwritten. Actually, on Linux system, it uses find. It shells out to find because that's a lot faster. On Windows, it uses like a custom implementation that just calls the file system. If you do not have Watchman, it means we have to, on every invocation of Jest, we have to get a list of all the files in your project every single time. So if you notice that Jest startup is slow, try to install Watchman, and it should be a lot faster. So that gives you a list of files. And then after that, we actually ask a module that wasn't always part of Jest, that we created specifically for Jest, and then other modules that build on top of Jest. It's called Jest Worker. So as you can imagine, after we get a list of files at Facebook, it might tell you, okay, there's a couple 100,000 files here. How do you spend time? How do you read them all like really quickly? And what we do with Jest, the light actually can be brighter. That's great. What we do with Jest actually, we look at how many cores do we have available on this CPU. Ideally, let's just use all of them to read all of these files as quickly as possible and give us this metadata that we want. The metadata being dependencies between files. So we ask Jest worker, hey, here are all the files we have. Please do this work as quickly as possible. And then Jest worker basically extracts that, builds up that haste context, and then it gives that information back to the Jest CLI. So I guess it talks back to Jest haste map, and then Jest haste map gives that haste context that I was talking about earlier back to the Jest CLI. All right, let me just do something really quick. Do you have any questions? Also, if anybody's watching this, if you have any questions, feel free to comment on this video or ping me on Twitter and I'll answer them. How do you guys feel about this? Do you understand? All right.
Yeah, makes sense.
I guess I can clarify the haste map, the haste FS data type a little bit. So this is basically a map data structure where the keys are the path to the file, I'm assuming, right? Yep. So I'm just going to call this path, actually it should be capitalized, it's flow type. It's path. You can find this type actually in Jest, and then you'll notice that this type is actually just a string. It's easier though for readability to call this path. And then the values here is like, we can call it a module. But that module actually basically has the module ID. Sorry, apologize for the writing here. Oh well, it's not much better. It has the ID. That's what I was talking about. That's Facebook internal. Most of your projects won't be using this. And then it also has the, mtime. Basically, it stores a value of when it was changed last. That is useful for when you're using Node.js, but also for the Watchman crawler to know what has to be updated. And then there's a number there. I think it's just whether it has been read or not. Might also be internal, not important. But then the next important thing is there's an array of dependencies. So it's just an array of strings which says this module depends on all of these dependencies. Great, so that's the HasteFS. So now there's a bunch of data types that actually flow back to Jest CLI. So at this point, after these 6 steps, nothing has been really done yet. It has just taken a lot of time and your test hasn't been run yet. What's important is now we have a new data type where we're just constructing, merging all of these things together. And we're calling this context. And this is just a simplified notation, but basically it has 3 values, but it has with it the haste context. That's important. All right, what else do we have here? It has the global config. All right, and then it also has a project config in it. All right. The important thing here is that for each project config, there would be one individual config instance. This is really just a normal object in JavaScript. All right, so now we've done all of this work, and we know, okay, we want to run some tests, and we have like all this data that we built up. And ideally, because there's a cache here and Watchman is running, this all takes less than, let's say, 50 milliseconds or 100 milliseconds, depending on the size of your project. If you have a very small project, hopefully that takes less than 50 milliseconds. So we're at this point, okay, when do we actually go and get to write some tests? Rubén is sitting there in the back, it's like, it doesn't take just 50 milliseconds. If you have a very, 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 very large code base, it might take a little bit longer. Okay, so the next step there is, okay, we have all this data, we have this invocation of running this test. Now we actually, this is not just a path to a file, Jest actually treats this as a pattern. So it will actually look at every single test that you have in your repo. The important thing here that Jest haste map now, that it has built up a list of all the files in your repo, that also means it has a list of all your tests in your repo. So we can very easily match and look at like what tests exist in your repository. So we'll look at the next step, step number 7. There's a class inside of Jest CLI that's called search source. All right, and that search source just gets all this data, and it's like, based on whatever is invoked here, go and please figure out which tests we're running. So I guess I can write that down here too, so it's a bit easier. Find tests to run. Okay. The question is, how does it figure out which tests to run? In this case, it's very easy. It has this pattern here. It has a list of all of the files that is passed on through this context, and then it can really just use regex to match over this list. Does any of my tests in my list match this pattern that test was invoked with? So I guess we can kind of annotate here some angle brackets, because it means you can put any pattern here. And then ideally, search source gives you a list of tests. There's also a data type here. Actually, it gives you an array of tests. And then test is defined as, I'm assuming it's a path, yes. I have a small little cheat sheet here, because I cannot remember every single thing. But there's a path. I'm also doing, let's do the single, the faster notation here. Again, there's a types folder in the Jest repo where you can look up every single type. So it has a path, then there's a duration. That one is a number. That's going to be interesting. And then there's the context that we were talking about earlier up there. All right, so that's ideally what the search source gives to us. But that is an unordered list of tests. So this is just, here are all the tests that I want you to run, but it doesn't tell you how to run them. One of the optimizations that we made in Jest is actually, we want to optimize for giving you signal as fast as possible. So we have this class, again in the next step. I don't know how far I can go over here.
Yeah, all the way up.
This far? Okay, great. So we'll expand here. The 8th step goes to a class called, what is it? The test sequencer. This is that part where we were actually running out of names to name our classes after, so it might not have the most ideal name. But the idea of it is that it receives this array of tests, which I guess we can just call tests. That also goes this way. I guess, I don't know if it makes sense to kind of, I guess if you listen you can kind of understand how the types are flowing through the system, but I don't know if I should annotate it. No, we're good? Alright. So anyway, these tests are passed on to the test sequencer. And that one is using a few very simple heuristics to appear very smart. It's not as smart as people might think, and there's actually a lot of room for improvement here. So if you're listening and you want to send some pull requests to Jest, now is the time to listen really closely and figure out what to build next. This is something where we could use some contributions, which would be awesome. So the test sequencer does a few things. It basically looks at all of the tests across all of the contexts, across all of the project configs. So in most projects that will just be the same context everywhere, but at Facebook you might have like 5 or 6 different projects that you're running at a time. So it looks at all of them and then determines what is the order that I should run these tests in. Regardless of how many CPUs we use, what is the order that we should run them in? And it does that with like very simple heuristics actually. It looks at, most of the time actually, so this doesn't really do anything that useful if it doesn't have any cache. If it does have a cache, it can make more predictable assumptions that are much better. So it looks at, has this test failed in the past? If it has failed in the past, it means it will run that test first. Are we still recording? Still all good? Okay. If this test has failed in the past, it will run those tests first. Has this test run in the past? And then based on how long it has, whether it has run before, if the test has takes longer, we'll schedule it earlier. That basically was just a trick to make it so that we utilize the CPUs as good as possible. Let's assume you have 3 CPUs and you run all of the fast tests across all of the 3 CPUs as quickly as possible, and then at the end, all the tests have run across all the CPUs, you have one test left that takes 3 minutes or something, and then you still have to schedule and run that test at the end. The optimization here is that if tests take longer, we want to schedule them to run earlier. That means that you run all of the slow tests first and all of the faster tests later. That means that if you have a few CPUs, let's say 3 CPUs, you have one slow test that will occupy probably the whole test run for one CPU, but all of the other tests can just run concurrently on the other 2 threads in the other workers. If we do not have a cache, we don't have this information, and then we fall back to the file size. That is a very simple heuristic, and it's also not a very smart one, but it's very fast to calculate. So it gives us approximate timings that are somewhat useful. So let's say you have a very large test file that's like 1,000 files, 1,000 lines. It probably takes longer to run than a test file that only has 50 lines. The problem with this is that some people write tests that only have 5 lines, but then require some very expensive modules that actually do the test run. For these, it doesn't work well. So as said, test sequencer, it's not the smartest module, but it works reasonably well. This is also the reason why when you're running Jest for the first time, and for the second time, and for the third time, the order in which tests are run and succeed, or finish running, might be different. So if you run tests 3, 4, 5, 6 times, the order will be much more consistent because it's much more predictable how long they're taking after a few runs. Now, the opportunity that you have to improve this is to actually figure out a way to predict how long a test takes with all the signal that we might have in tests. So you can do a bunch of static analysis. You could check for how many calls to test or it or describe or something like that are in the test file. And if there are more, you can assume that the test probably runs longer. There might be other ways that you can predict how long a test might run. But there might also be a way to figure out which tests are actually very important to run based on the change that we're making. So as I said here, you can specify any certain pattern. In Jest watch mode, what we can do is we can actually look at which files have been changed in this repository, and based on these changed files, let's do a reverse lookup to all of their test files and run them. At the same time, when you're working at Facebook and you work on the React code base, for example, if you make one change, it would trigger a run for the entire test base at Facebook because everything depends on React. So that is not very useful. So one thing we could do here is actually figure out, so what was I saying, test priority. Let's call it test priority. Question mark. All right. So one thing that we could figure out is how important is one test if we change a file here, if we change a file in one place. So an example of that is, let's say you change a file, whatever it is, and you want to run all the tests that are really important to run really quickly, and then you can schedule all the other tests to run later. And the way you could think about this is you look up in the dependency graph that we have here, all of the files, so I change one file, and you look up all of the test files that directly depend on that file. That usually means that's like really a unit test for that specific file. And then you assign those a higher test priority than other files that only depend on that file through a layer of 10 other files. So those are a bunch of very interesting things where we could figure out, first, how we can be smarter about the test run, but then second, if we only have a limited amount of time and we want to give signal quickly to people, what is the best way to schedule the most important 10 tests out of 100 tests to run them quickly, and then people can get signal, and then the other tests can just run afterwards when somebody has gone back to already writing code again or fixing things up, and then see those results later. Okay, so before we go on, one thing that I want to point out here. So I said earlier that the search source just finds the tests to run, and what it does is it takes the list of all the files in the system and like the pattern that is being put in here. The important thing here is actually this is not modularized yet, so it could be a separate package, just like Jest CLI, Jest config, Jest tastemap. Could be like a Jest search source package, naming by Rick. It's very smart. The idea for that could be actually, and that was actually the long-term plan that we never got around to, is to modularize this so people can actually, through the project config, specify a list of search sources for each individual project. So it could be more than just one. So instead of going to the file system to locate which tests to run, you could theoretically ask a remote service to say, okay, which tests do I have to run? Which tests are available? You could ask a system. At Facebook, we use something called Bug, which is our build system, but it also provides the capabilities to run tests. You could ask Bug, hey, you can issue a query like, hey, which tests shall I be running based on this pattern? So the idea for the search source is to be completely generic and not just be this abstraction around matching tests to a list of files on the file system. So it could be really anywhere. And theoretically, as you might see later, is that Jest can also run tests that are located somewhere else. So through this, you could actually make it so you do a local run of Jest. It will actually go find tests on a remote machine to run and run them on a remote machine and then come back with the test results. So there's stuff that you could do here to actually improve this. As I said earlier, the test sequencer, we could benefit from a test priority system. It's not the smartest thing, but it works reasonably well. One important thing here is that focusing on performance is not just the raw performance of how long a test run takes, but it's also about the perceived performance. It's all about user experience. For example, when you have a test that failed previously, it doesn't make sense to run that test last. So this is actually a pretty good heuristic, because when you have a failed test and you make a change in your code and you rerun the test, you probably want to see if that test passes now or not. So that actually really improves user experience and iteration speed, because as soon as you see everything green there, you're like, okay, I fixed my thing. If you see things red, you should look more closely, and we want you to get that information as quickly as possible. So moving on, now we have done all of this work and we still haven't run a single test. We're gonna go to a 9th step. I don't know how much space I have here. Was that like up until here? Nope, here?
Yep.
Okay, so that's gonna be close. I don't know how far we're gonna get today. Maybe I'll just go a little bit up. So the 9th step is going to be our test scheduler, and that one is actually pretty important. So we call it test scheduler. As you can imagine, previously test sequencer was called test scheduler, and then we had to rename a bunch of stuff. That's why we came up with all these awkward names. Anyway, what's important here is that this is the actual system that figures out, based on the list of tests and based on the sequencing that we want those tests to run in, how do we actually run them optimally? And the first thing that it does is it looks at, do we want to run this whole thing in band? And in band basically means run on in the same process that the Jest itself runs, or do we want to schedule, create a bunch of work processes and then schedule the test runs over them and then get back those results? This one is also responsible for creating the reporters. So if you have like specific custom reporters, it creates them, gives them information, and then shuts them down at the end again. So this one is probably the most important module, most important class to actually make sure that your tests run. We actually extracted some stuff out of this to make Jest more generic. If you use Jest, for example, with Puppeteer, I don't know if there's other examples for Jest runners. Do you have some examples?
ESLint.
There's a way to run ESLint through Jest. So we abstracted a bunch of the logic out into this package called Jest Runner. So one of the cool things is, so this is a full package that's in the Jest repo, but through the project config, you can actually completely swap out this Jest Runner to, for example, run Jest using Puppeteer. That one is pretty awesome. So the way this works is it gets this list of tests, and then it does another simple heuristic. One thing that we noticed is that it takes a really long time to start up worker processes. A lot of very, very small projects only have let's say 3 tests or 20 tests or small amount of tests that all run like very, very quickly within the tens of milliseconds. For those, it actually doesn't make sense to, even if we have 10 tests, to spawn like 10 processes and run the tests in workers, because the startup time for Jest is actually, for Node and Jest is actually higher than it takes to run those tests. So if Jest realizes, okay, these tests are all like really fast and there's a very small amount of them, just run them in the same process and give back some results. So that's what the test scheduler does. That's also a very small optimization that doesn't sound very smart, but has a really big effect on user experience. So then it delegates to Jest runner and says either run them in the same process or run them across a bunch of other processes. And then we'll call back to another, if you're using the default configuration, you stay within the Jest ecosystem. We'll call back to another package that we used earlier. It's called Jest worker. Terrible handwriting here. This is supposed to say Jest. And it actually tells, hey, Jest worker, create however many processes that we need, set everything up, and then run those tests. The cool thing about the Jest worker project, as you can see here, I mentioned it only very briefly, you can actually drop that in anywhere in your own projects to parallelize work across processes in Node. The cool thing about Node 10 is that it actually has this functionality built in, and Jest worker is soon going to have the ability to also benefit from that threading module, or is it processes or threads? I don't actually know, but it allows you to parallelize work. It's good enough for me, so Jest worker is going to enable that. So just drop it in because it's also going to work on all versions of Node, and you can parallelize stuff across processes. All right. Yeah. Okay. So in the normal Jest run, this will then go to probably. Are we talking about Circus or Jest Jasmine? It will go to one of those and run the tests. So we have Jest Jasmine 2, because as you might know, that the Jest APIs that you're used to when you're running writing tests, they're actually using Jasmine under the hood. It used to be actual Jasmine, but then we stripped out everything that we didn't need and made it much lighter. It's still called Jest Jasmine 2. At the same time, Aaron from the Jest team and a bunch of other Jest contributors worked on this thing called Jest Circus, which is a completely new test framework, which is inside of, which provides the APIs like describe, test, and it, and all that to make it so that your tests can actually be run. And it uses kind of like a Flux architecture to build up your tree of which tests have to run. And it's a lot more obvious to figure out how tests are run, and when your tests get stuck, you can kind of debug and rewind and figure out what happens. This one is not the default in Jest as of November 2018, but it might become the default soon. We're actually already using that at Facebook, thanks to Rubén. Thank you so much. So just continuing here, that's the 11th step. This one then actually creates a bunch more things. So it creates that test framework, the APIs. But it uses a module, that one is very important, it's called Jest runtime. Alright, that module is actually, if you've used Jest, you might know that one of the great things is when you run multiple tests, they're all running in isolated environments. I was talking here about how they're parallelized across workers, across different processes on your computer, but Jest runtime actually makes it so that each test, even if it runs in the same process, will be run in a different context. And in this case, I know we've used context here, but in a different VM context. That is a module that is provided by Node.js. So there's a module called VM. That's part of Node.js. You can use that to create a context for running JavaScript in isolation. The important thing here, this is not a secure kind of like environment. You can break out of it. For test frameworks, that works really well because we trust all the code that we're running on it. The great thing about it is it allows you to create a new context. You can specify your own global scope, so you can kind of set up the environment that you want. If you're using JS DOM, we can set up all the DOM APIs. If you're using a Node environment, we make like a fake Node environment. And also we provide a require implementation here. So Jest actually has a custom require implementation that allows you to require modules. Through all these optimizations that we're doing here, we can actually reduce the amount of file system operations we're doing. So it actually is really fast. The great thing is also if you've used the mocking system in Jest, where you can actually swap out modules at runtime, you can call jest.mock some module and then require it later. All of that happens in here. So it basically has a runtime system of like figuring out what module should be required, whether the real module should be required or the mock should be required. So if you want to dig into some code, the Jest runtime module is very interesting to look at. I've talked about this a lot, actually. I should write it down. At the same time, there's also the Jest environments. Oops. Okay, so this is just a star because there's multiple environments. This is also the same step, mainly because this test runner, this test framework that kind of creates the runtime also creates those environments, and that might be Node or JS DOM. I've called back to that multiple times. So this is where it's created, and then it's passed on to this Jest runtime, which runs all the tests. In this part is also when we actually do the transformation for modules. So let me just write down what this all does. So I mentioned it does resolution of modules, so it has a require implementation. It does mocking, and then also does transforms. And transforms, that is, for example, when you're using TypeScript or Babel, that's how you transform your actual code. So the important thing that I want to point out here is I talked about how we can provide some implementation for the global object or for the module system that runs in this context. So the way it works is the require function is something that Jest runtime injects into this VM context. And then when you require a module, Jest goes outside of this sandboxed context where your test runs back into Jest runtime, and then it looks at, okay, what module is this what module is this test requiring, and then looks at whether this module has to be transformed using Babel or TypeScript based on whatever project config you're specifying for your project, and this happens synchronously. The reason why that is because this function require is synchronous, and we do transformation just in time. A lot of people in the past have asked, hey, wouldn't it be great if this transformation could be async because I want to do certain things where I need to wait for the result. The reason that we cannot do it is because of this. Basically, we transform every file just in time when it's required through this system. If we were to change this transformation to be async, we would have to go all the way back here basically to before we run a test, so either here or somewhere around here. Well, it's probably going to be around here, but before we run a test, we would have to figure out which are all the files that are going to be required in this test run, and then transform all of those files. Depending on how people include their modules, some people don't stick to the require convention. They might have certain magic to require an entire folder based on one specific import. It might be pretty hard to get a really accurate dependency graph here, so it's pretty hard to do those transformations ahead of time before we run the test. So we could either decide transform all of the files in this repo, that would take a very long time, or just do them just in time when we need them, and that saves time. This is also why the first test run often takes a lot longer. So what I've been talking about, the first test run, all of these steps, there's a lot of caching here involved to make Jest fast on subsequent runs, but Jest haste map might take a long time the first time you run it on a big project, but then also transformation often takes a very long time. Both of these are cached. There's also the test sequencer which optimizes runs, so there's also a cache here. So that is why the second run is usually a lot faster, up to 50% or so. That's mostly because transformation often takes more than 50% of the entire test runtime. So once that is cached, the second, third, fourth runs, they're a lot faster. So if you're trying to measure the time it takes for a test framework to run tests, if you're evaluating Jest, I would definitely always evaluate the initial runtime and then so the first invocation, and then also the third, fourth, fifth, and then kind of average over that. But definitely consider the first run and the subsequent run separately. So that's what I have here. I'm not sure how much time we've left. Just a few minutes, right? What do you think I should talk about? There's not much else on the cheat sheet that I have. There's obviously a lot more to talk about Jest in general, but this is kind of the general architecture, and we did a deep dive on everything that it takes to go and run a test. We haven't really talked about what happens when you're running the test and what happens, how that all goes back to give you a test result, right? But
I think the way that the test runs will depend on the runner, but one part that's constant is how it gets back from the runner back to the reporter with the test results.
Right, yeah, okay, so one thing, actually, we have a type here. We can call it test result. That one is interesting, good point.
That's too high.
That's too high, so I just wrote something and I'm going to write it again here. That should be readable, right? Because otherwise this is also cut off. Good. So there's a type called test result. Let me just erase whatever we have up there. It's confusing. All right, so there's a type called test result, and that is basically just a mutable JavaScript object where as soon as the test results come in, either Jasmine or Circus will just update the data in this test result. So basically it says, has this test file passed the run? Which tests are in this test file? How long does it take? What is the name of these tests? What are the errors? What are the stack traces? It is much more interesting when a test is failing than when it is passing, because then it will have more data. And then that will be populated through this. And then one important thing that I haven't talked about is that all of this data has to be JSON serializable, because it goes over this bridge in Jest Worker where it has to pass data from one process to another. There are certainly tricks that you can employ to do this with data that is more complex than JSON serializable data, but in this case we keep it simple. So we serialize this data and give it back to the Jest runner, and then this test scheduler in this class, this is also something that could be cleaned up and possibly moved out to separate packages. I said earlier that this one is responsible for creating the worker, the reporters. It's also responsible for collecting the data from test results. So this test scheduler has some callbacks where once a test is passed, it will invoke those callbacks. Once a test is finished running, I should say, we will invoke those callbacks. If it has passed, it will do certain things. If it has failed, it will do different things. But most of the time, there's an aggregated test result here. So that also is similar to the test result type. This one is also a mutable JavaScript object where every time a test finishes running, we just modify this object to add more test results to it. And that also then basically has properties like, has the entire run succeeded? Has everything passed? How long does it take? What are all the test results? And then through that, you can kind of dig into what is going on with your test run. And those reporters that are hooked in here, I don't know how to, I'll just write reporter here. Oh, see, this is where the color scheme breaks apart. I see now. I get it. We would have to write it in red. We would say reporter. Okay, I'll just write down reporters here. So all these test results are passed to the reporters each time when a test finishes so that they can print certain messages. By default, it will just print pass the file name, and then if it's slow, it will tell you how slow it is in red. If it fails, it will print out the fail message, the same things, and then also the error and the stack trace if it can. One important thing that I want to point out in the default reporters and the default printing of test results, we really tried to get the user experience right there as well, because in the past everything was just one color and it wasn't very useful, but we actually really tried to align the green colors that you see, the red colors, and try to gray out and dim things that are not as useful to read. So a lot of work goes on in the reporters, and there's like some printing logic that we could also consolidate more into the reporters. But basically that goes all the way back up here, and then we basically just go back to the Jest CLI, and then based on whether this test has succeeded or failed, it will basically put in the right exit code and then bail out and quit the process, unless you're in the watch mode, and then we'll just stick around, listen for changes. One thing that's interesting, Jest watch mode uses all of this the same way, but it has some small optimizations on the way as well. One of the cool things is that Watchman actually provides, next to being able to ask, hey, what has changed on the file system since the last time I asked you what has changed, it also allows you to listen for those changes. So when you call Jest with --watch, to start the watch mode, it will actually here, it will ask Jest haste map, because that now has a watcher to talk to Watchman or Node, hey, listen to all the file changes and tell me what has changed. So based on file changes, Jest CLI basically says, okay, whatever is changing, give me the new haste map. The great thing is this also has an optimized system here, so that when a file changes, it only changes whatever is necessary to change. It doesn't crawl your entire file system. It also does this thing where it batches file system changes, so it doesn't give you, when you like change from one Git branch to another, it doesn't give you like 100 file system change events. It will basically batch them up every 30 milliseconds or so. It gives you a list of all the files that have changed, so that it doesn't like kind of just call this thing all the time to rerun all the tests. So basically, Jest CLI listens to Jest haste map, hey, what is changing? And then Jest haste map tells the Jest CLI what has changed, and then Jest CLI goes through all of these motions to rerun a test, print a nice message, tell you how to use watch mode, and then it goes through that again. I think this is probably a good place to stop for now. I hope that you enjoyed watching this deep dive. I'm sorry it wasn't like the most polished thing we could do, but I hope this is useful for you and that you could learn something. If there's something specifically here that you would like to hear more about, or something that we haven't talked about, just let us know, and then maybe we can do another one of these. All right, thank you so much.